It may seem improbable, but many coastal tidal marshes are drowning. Shimon Anisfeld, director of a 4-year-long research project at the Yale School of Forestry and Environmental Studies, has been monitoring Long Island Sound's tidal marshes. The tidal marshes are critical to maintaining wildlife habitat and coastal communities.
Drowning marshes are areas where we're losing the vegetation, we're losing sort of the base of the food chain, the high productivity, the organic material that provides food for the invertebrates and then the vertebrate consumers. And so ultimately, a degradation, a loss of those habitats is a loss for the wildlife that depends on them. In addition, marshes are thought to provide an important buffer for coastal communities against storms, against erosion. And as those marshes themselves are eroded and become open water systems, become tidal mudflat systems, they provide less of a buffer. They don't slow water down as much. Sea level rise is overtaking the ability of the marsh to keep up. So the sea level is rising more rapidly than the marsh surface is rising.
Professor Anisfeld and his team created plots in Guilford and Westport, Connecticut, to test whether fertilizers are causing the drowning.
What we're doing here is we're actually manipulating the marsh. We're adding nutrients, that is, we're adding nitrogen and we're adding phosphorus, sort of fertilizer to the marsh, to see what happens. And that is really to test the hypothesis, to test the idea that too much nutrients is bad for the marsh and can lead to drowning. The possible links between adding nutrients and drowning are really twofold. We know that adding nitrogen to marshes will increase the above ground production, increase the plant material that you can see, and that's not going to lead to drowning. But our concern was that it would lead to less productivity below ground, that is, less organic matter, less material growing below the surface, and that it would lead to higher decomposition rates, that is, greater loss of material below ground. Those two combined or even separately could lead to less material in the marsh peat, in the marsh sediment, in the marsh soil, and lead to degradation of the marsh. And the logic is simply that the plants use the roots to get nutrients. If they have higher nutrients available to them, they don't need roots as much. So what we set up here at this stable marsh were a set of 24 plots, and they were divided into 4 different kinds of treatments, so 4 different things we did. One was a control, where we didn't add anything, just monitored the marsh. Second type of treatment was adding nitrogen and monitoring the marsh. Third was adding phosphorus and monitoring, and the fourth is adding both nitrogen and phosphorus together.
Professor Anisfeld suspects the lack of sediment rather than the presence of nutrients could be contributing to marsh drowning.
So what we've seen, at least so far, is that the nutrients certainly make a difference in terms of the above ground productivity. As we expected and as other people have shown, adding nitrogen does lead to higher above ground production, and you can see it actually very clearly in the marsh. The nitrogen fertilized plots are taller, more productive than the controls and then the phosphorus fertilized plots. In terms of the below ground, which is really what we were after, we didn't see large differences. So at this point, we're not inclined to think that nutrients are an important part of the drowning equation, and we're looking for other explanations. The things we want to look at next are the ideas that came out of the first phase of this project, which really did not support the nutrient link, but rather pointed us more in the direction of inorganic processes, that is, the sediment that is being delivered by the tides, the hydrology of the marsh. We're going to continue the fertilization experiment. We want to kind of pin down the effects of the nutrients here, but we don't think that's the main cause of the drowning.
Marsh drowning may be the result of sea level rise, which will accelerate as the world gets warmer.
Sea level has been rising in Long Island Sound for thousands of years, since the last glaciers were here. And as the glaciers melted, a lot more water went into the sound, and that water warmed over time, and so sea level has been rising. In Long Island Sound, the water was rising at about 1 millimeter a year, and then about 150 years ago, it about doubled to about 2 millimeters a year. It seems pretty clear that global warming, that anthropogenic climate change is leading to a warming of the oceans, which is going to lead to an increase in the rate at which sea level rises.
For more information about Professor Anisfeld's work and the Yale School of Forestry and Environmental Studies, visit environment.yale.edu.